whether they want to find out whether you know that quinone is the same thing as zetten. All right. And so if you're also suspecting nocardia or Mycobacterium leprae or Cryptosporidium, all of these are all positive for zetten. And so they also show positive for quinone, except that when you are dealing with these ones, know that they are less acid fast or weak acid fast, and therefore there will be the requirement to modify your acid to a lower concentration. Is that all right? Good. Then the next stain you want to talk about is India ink stain. The India ink stain. This is a very simple stain you also use in microbiology. And India ink stain uses the principle of negative staining. So normally when you are staining, the dye will have to penetrate into the organism and impart its color into it. All right. Now with the India ink, it doesn't penetrate into the organism. It rather stains the outside of the organism. So it means that even though you are staining, but looking at the principle of staining, which says that the dye must penetrate. If the dye is not penetrating, but rather just staining the outside, then it becomes a negative. So negative staining is where the stain does not actually penetrate into the organism, but rather stays outside. So once it stains the outside of the organism, you see that the organism will lie within the preparation unstained. Okay, the organism will lie within the preparation unstained. And so this is where we use it for Cryptococcus. And you know that Cryptococcus is a type of fungus. Okay, Cryptococcus is a type of fungus. So sometimes they just want to find out which of the following stains is useful in fungal tests. Okay, if they mention India ink stain, you should know that India ink stain is used to test for Cryptosporidium. Sorry, Cryptococcus. Sometimes you can easily confuse Cryptosporidium and Cryptococcus. Cryptosporidium is a protozoa. That's where you talk about the zetten. All right. I'm not going to talk about Cryptococcus. Cryptococcus is the fungus. They will normally cause meningitis. So we call it fungal meningitis because Cryptococcus is a fungus and it's causing meningitis, becomes fungal meningitis. And if there's a suspicion for fungal meningitis, past specimen will be collected. It is CSF. The CSF. So you take CSF and then you just apply a drop of India ink stain. Sometimes, in order to maximize the recovery of the organism, you spin it first. When you spin it, the CSF, you are trying to concentrate the parasites or the organism, the Cryptococcus. So you spin, take out the spanitent, and then take a drop of your sediment and apply your India ink stain, and then just cover it, the cover slip. Examine under the microscope. You are going to see what we call a haloing. If some of you are colors, halo. You see, if you come, whenever they draw St. Patrick, St. Peter, St. Lucia, and so you see that the head, they will throw a light around the head. Whenever, I'm sure that's called a halo. So when you have Cryptococcus lying in the mid of India ink stain, you will see that Cryptococcus, because it has a capsule, the capsule tries to repel the Indian ink stain, which, remember I've told you that Indian ink stain is used as a negative stain. So it is just staining the background. And then the Cryptococcus, because it has a capsule, it is also trying to repel it. So you see that organs are lying there, and there seems to be a white how do you call it, covering around the organisms. And so that's why we say it's a halo. It is just like the St. Peter's, the St. Joseph's picture where you have a light around the head. So that's how it is described. So you see a halo around the organisms, and that is actually a detection of the cryptococcus. All right. So remember that cryptococcus is also a fungus. So if they give you a couple of stains and say which of these stains is used in fungal studies, and they add Indian stain, remember that it is part of the stains that is used for fungal studies, because that is the stain that is used for detection of cryptococcus, and cryptococcus too is a fungus. So they will not see. Sometimes they put the question in such a way that you may forget that cryptococcus is also a fungus. All right. So I'm sure that will be dealt with whenever you are able to meet any of them. The next one is the Oramin rhodamine. Oramin. Now, I'm sure some of you have worked on TB cases before. These days, most labs are not even using the Zetten stain. They are using the Oramin. The Oramin is a fluorochrome. When you say something is a fluorochrome, first, it's a combination of fluorescence. Fluorochrome is a fluorescence of fluorescence, and then chrome. Chrome is a color, okay? And fluoro is coming from fluorescence, so it's fluorescence. Fluorescence is when an object is able to take light of a shorter wavelength and give it out at a longer wavelength. You see that with a shorter wavelength, our eye cannot perceive it, cannot see it, but a longer wavelength, we can see it. So it is going to take light which cannot be seen to a light which can be seen. So that's the fluorescence. And then the chrome is now giving you a color. So it means that this is something which can pick light and then let you see it, and even let you see it in a color form. So that is the principle of the Oramin. Oramin and rhodamine is a mixture. All right. So the mycolic acid, which we have described as the major component of the mycobacterium, the mycolic acid have affinity for Oramin. Okay. So, and we say the Oramin too is a fluorochrome. So what it means is that the Oramin will attach itself to the mycolic acid, and now under a fluorescent light, okay, under a fluorescent light, that organism now will begin to emit a specific light, and the light here is normally a yellow light. So you see that it is now very simple. You don't need much stains, you don't need heat, you don't need anything. All you need is to mix your sputum. If you are dealing with your sputum, just mix it with your Oramin stain. So the Oramin in the stain will, because it has affinity for mycolic acid, will attach itself to the cell wall, and now it can now be seen under a fluorescent microscope. And you know that we are saying that it's a fluorescent chrome, and we are saying that it's going to give you a color. So you see it giving a certain light, and that light is yellow. So you see yellow rods under the fluorescent microscope. Very, very, very simple. Very, very simple. All you need to know is that in the Oramin stain, apart from the mycolic acid, which picks up the Oramin, there could be other artifacts which can also pick up the Oramin. Okay, so if you don't take care, you are going to report everything as also AAV. So a way to reduce the tendency of artifacts giving you the same color as the what do you call it, the mycobacterium, is try to use a counter stain which also has the capacity to quench. Remember, we are saying that this is going to give you a light. All right. So if you put up the light or something, we say you are quenching it. All right. So the counter stain which is used in the oramine stain is potassium permanganate. Potassium permanganate is serving as a counter stain, at the same time is going to serve as a quenching agent, so that all the artifacts which are picked up the oramine will be put off. Remember, we said the oramine is going to give off light. And so if you put off the light of something, say you have quenched it. So that is sometimes where they ask the questions. That the potassium permanganate, all people know that is used, in the oramine stain. All people know is that potassium permanganate is used as a counter stain. They forget that it is also serving as a quenching agent. All right, so that is the area you have to watch out. If they are asking you questions about oramine and they bring in potassium permanganate, they want to know that the potassium permanganate is also serving as a quenching agent. Otherwise, you report so many positives, which are not real positives. The risk there is that if you over apply the potassium permanganate, then in as much as it is quenching the light from the artifacts, if you over apply it, it will also quench the light which is being given off by the microbacteria. That's all. So you don't have to over apply the potassium permanganate because it is not specific for quenching the light of the artifacts. It is quenching all light, but it has the capacity to quench off the light of the artifact faster than that of the microbacterium. So that's what you have to know about. Then potassium hydroxide. I brought this one here because sometimes you can come across a question which will bring certain reagents and ask you which of the following is applicable in fungal studies. Okay. All of you know that when you have skin scraping, okay, if there is a dermatophytes, skin lesions which are suspected to be fungus. Now the scraping, if you scrape the skin, you are looking for fungus. So in skin scraping, we use 20% potassium hydroxide. I'm sure you know this already. Right. So you use potassium hydroxide, then you apply it to the scrapings that you have made on the slide. Then you add a drop or two of the potassium hydroxide. The potassium hydroxide is to dekeratinize, is to remove the keratin. You know, the skin has a lot of keratin. You can either use the skin or the nails. You know, the nails can be affected by fungus. So you can take clippings from the nail. The hair can be affected by fungus. You know, you have the tinea capitis, which people normally call the ringworm. So you pull off some of the hair, and then you also apply the 20% potassium hydroxide. If you add the potassium hydroxide, what they do is to dissolve the keratin. Once they dissolve the keratin, then it exposes the fungus, either the spores or the hyphae. Right. So it means that potassium hydroxide is an agent which is useful in analysis of fungal studies. Okay, right. Then there is another stain we call lactophenol cotton blue stain. Lactophenol cotton blue stain. It is also used in fungal, especially when you have done your cultures. Okay, when you have done fungal cultures and now you want to identify the fungus. Okay, we apply lactophenol cotton blue stain, and then the lactophenol cotton blue stains all the spores, all the hyphae for you to be able to identify them under the microscope. So I'm just bringing all this one for you to know that these are some simple states in microbiology. And once you have ideas about how they are used and in what areas they are used, I'm sure that questions around these ones, you should be able to answer them very easily. Okay. So let's try some few questions just on the what do you call it? The stages that we have discussed. Before then, will anybody want to ask a question? Will anybody want to ask a question on what we have discussed so far? Or we proceed with the questions? Okay, so let's proceed with these questions. All right. So, which of the following statements regarding macroplasmas is not correct? Is not correct. Remember, I've told you that macroplasmas belong to the group of organisms that are said to be cell wall deficient. Okay, they are cell wall deficient. All right. So let's see how the questions go. Right, macroplasmas are the smallest free living microorganisms. Is this true or false? Because it says which of the following statements regarding macroplasmas is not correct. So we are looking up for those which are correct. Is that right? So in this one, is it correct or not correct? We are all discussing, please. Macroplasmas are the smallest free living microorganisms. Correct or not correct? Yes, sir. Anybody? Yes. Portia. Portia, I could see that your mic is on. Is Portia on the line?
Yes, sir.
I could see that your mic is on. So can you help us? All right. So it is true that it is the smallest of the microorganisms. All right. So that will not be the answer. Macroplasmas are resistant to cell wall active antibiotics. Is this correct or not correct?
It's correct. So it's correct.
Very good. Remember, we said that they are cell wall deficient bacteria. So once they are cell wall deficient bacteria, it means that antibiotics whose activity depends on the cell wall will not be able to. And for the MLSD, this is also an area that you have to watch out. So in your area, they can ask macroplasmas or let me put it this way, the beta-lactams. Okay, beta-lactams are unable to be used for treatment of mycoplasma or chlamydia infections. Okay, you understand? So because you know that we have some MLSD people with us. Any MLSD with us?
Yes, please.
Okay, all right. Okay, so now I can go ahead. So if they ask you why chlamydia, for example, cannot be treated with the penicillins, for example. You see that penicillin is a B-lactam, okay? And for the B-lactams, they have their binding size is on the cell walls. We have, for example, protein binding beta-lactams, which are situated within the cell walls. So if you have an organ that doesn't have a cell wall, then automatically it means that it will not have a binding site for the beta-lactams. Okay, so that explains why any of the penicillin groups, the cephalosporins, any of the beta-lactams cannot be used to treat chlamydia and for that matter, mycoplasmas. I'm sure as we move along, we'll get to that stage. But this is a simple thing that you should know that it is correct that mycoplasmas are resistant to cell wall active antibiotics, because you just said that mycoplasmas don't have cell walls. So if they don't have cell walls, they will automatically be resistant to cell wall active antibiotics. And therefore, this question is correct. Here we are looking up for which of the following is not correct. So A is correct, B is correct, so that cannot be the answer. Mycoplasmas are common commensals of the respiratory and urogenital tracts. This you may not know, but that's also correct. Okay, mycoplasmas are normal commensals in the respiratory and the urogenital tracts. This is where the trick is. Mycoplasmas stain well with the gram stain. Okay, so I try to bring this question just because we have had some discussions on the gram staining. All right. So mycoplasmas, they stain gram negative. It's just by default. I hope that you understand me. They stain the gram negative by default because they don't have a cell wall, and therefore automatically they have to stain gram negative. So you can't say that mycoplasmas stain well with a gram stain. It doesn't stain well as such. I hope that point is clear. So as far as this question is concerned, your best answer will be the D. Do you agree with me?
Yes, sir.
Okay.
Yes, please.
Yes, sir. All right. I think I have a question here, but I'm not sure it is very appropriate, but let's see. A gram stain of spinal fluid collected from a 3-day-old baby shows short gram-positive rods. This organism is most likely to be. All right, so as we move along, we will be dealing with specific specimens, but I'm sure this one, because of its relatedness to the gram stain, that's why I picked this question. So in the normal CSF, our emphasis have always been on strep pneumoniae, Haemophilus influenzae, and what? Who can help us? The classical organisms that we're looking up for in CSF. Can anybody help us? Strep pneumoniae causing pneumococcal meningitis. Yes, Haemophilus influenzae. Which is the third one? Neisseria meningitidis. Okay, so these are the classical organisms that we'll be looking up for in CSF. However, in the neonate, I'm sure you know neonates. Neonates are newborns from day 1 up to the first 28 days, or what people say 1 month. The first 1 month of life is called the neonatal age, neonate, right? The neonates or the newborns, if they have meningitis, the organisms which likely cause meningitis is not the Haemophilus, strep pneumoniae, no. It's rather Listeria monocytogenes and then strep B. Okay, these are the organisms that are most likely to cause neonatal meningitis. Listeria monocytogenes and strep B. However, strep B, as you know, it is a streptococcus, and therefore it is gram-positive cocci in chains. Is that all right? Good. Now, the next organism to consider will be Listeria. Listeria is gram-positive ROS. So sometimes, especially for the diplomat, sometimes they will list a group of organisms and ask you which of the following are gram-positives. Okay, those ones are very, very simple. So you should be able to know some few common gram-positive ROS and some gram-negative ROS, and some common names. And so with this particular one, if you are seeing short gram-positive ROS in CSF, what organism is it likely to be? Yes. Please, I need answers, please. With the discussion that we have had, yes.
It will be
A.
It will be strep.
Listeria monocytogenes.
Yes, Listeria, because I've told you that the strep group B, Streptococcus is gram-positive cocci in chains. Okay, strep group B. When you have Streptococcus, we group them according to their hemolytic state. So we have beta hemolysis, we have the alpha hemolysis, and then we have the gamma hemolysis. Okay. Now, so we group them as such. Then if you come to the beta hemolysis, we are looking up for group A. Yes, we can tell us some of the groups in the beta hemolytic group. There's beta hemolysis. If you have beta hemolytic strep, which groups are you considering? Hello?
Yes, I want to try.
Yes, please do.
Streptococcus pyogenes.
Okay, that is group what? What group is that?
Group B.
No. Strep pyogenes is group A.
Okay.
Okay. All right.
Okay, sir.
Then again, yes, try more. We are looking at the group that constitute the beta hemolytic and in the streptococcus group. So we have the group A, we have group B, we have group C, we have group F, we have group G. They are all beta hemolytic strep. So that's why it is important. So if you have beta hemolytic strep, right? So we are going way beyond the question. So if you have beta hemolytic strep, it's either group A, group B, group C, group G, group F, all of them can be beta hemolytic. All right. Now, so if you want to rule out the group A, okay, you do the basic tracing. Do you remember? You remember the basic tracing test? Hello? Do you remember the basic tracing test?
No, sir. Please.
Okay, so you take time and deal all these ones. But because of the time space for this program is too short, so we will do more questions than actual topic. Okay, so once we have something like this, and then we push these ones in. Otherwise, we may not be able to go far. So let's try and do that. So with the group A, you do bacitracin. Bacitracin is an antibiotic, and it is sensitive for strep group A. Okay, so if you have beta hemolytic strep and you want to rule out the strep pyogenes, which is group A, then you prepare a disc do you know the long cultures? No, the long culture. Long culture, although you are doing sensitivity testing, you spread the organism on the surface of the plate. All right. Then you put on, although you are doing sensitivity testing, then you put bacitracin. It's also a disc. If at the end of the day there is zone of inhibition around it, then it means that it is susceptible. Okay. Once it is susceptible, then it means that it is group A, and for that matter, it is strep pyogenes. I hope you are following it. Now, if it is resistant, you cannot conclude that it is strep group B, because remember we said that a whole lot, the group A, group B, group C, group D, group F, they are all what do you call it? Alpha hemolytic. So if the bacitracin is resistant, it could be any of them. All right, so you do another test we call the CAMP test. Have you heard about the CAMP test, please? Hello? Hello?
No, please.
No, okay. So the CAMP is an acronym. When you say something is an acronym, what does it mean? When you say something is an acronym, please,
It means the component. The spelling has its. There are some words being.
Very good, very good. So it means that it is an abbreviation. Okay. So when something is an abbreviation, it means that it's a short form of something. So when that short form sounds like a word, then it becomes an acronym. All right. So for example, you have CLED. You know, CLED is a short form of a group of words, but it is sounding like a word, CLED. So it is 16 lactose electrolyte deficient. All right. So it is forming like a word. Similarly, CAMP is also an abbreviation. All right, but it is sounding like a word. So the C stands for something, A stands for something, M and P all stand for something. And C stands for Christie. You see, there were 3 scientists who observed a certain phenomenon. Okay, and so that phenomenon has been credited to those 3 scientists. And they have to craft their name in a manner to form like a word. So Christie Atkinson, A, and then MP is Munch Peterson. Munch Peterson is also like say like Atkinson or Mason. I mean, it's a hyphenated word. So it doesn't make it 4. There are rather 3 because you have the Christie, the Atkinson, Munch Peterson is 1 person, but it has a compound name. So they crafted their name in this way and then called it as a CAMP. So it is a phenomenon they observe. That phenomenon is positive for strep group B. So what it means is that if you see beta hemolytic strep, all right, and I'm sure you know what beta hemolysis, that around the colonies, there's clear. I mean, the red cells have been hemolyzed, and the place becomes very clear, pale. All right, so that's alpha beta hemolysis. So that clear hemolysis can be either group A, group B, group C, group G, and group D. And I'm saying that the first thing to do is to rule out group A by doing the bacitracin test. If you do the bacitracin test and it is sensitive, you confirm that it's group A. Okay. If the bacitracin is resistant, then you want to do other tests. And I'm saying that the next test to do is the CAMP test. CAMP test, I think subsequently I will explain it further. CAMP test is a test that's based on a principle we call hemolytic synergistic hemolysis. I'll demonstrate. Since you don't know about that, I think I have to prepare on that one and demonstrate it to you. So When your CAMP test is also positive, then that's group D. All right. And then if you do you have what you call last week grouping, where you can do for all the various groups, group A, group B, group C, group D. That is the last week grouping. But for the purposes of this question, we are saying that Listeria monocytogenes is gram-positive ROS. All right. And the strep group B, they are gram-positive cocci. So they are two complete different organisms. As for the contaminant and the anaerobic, it's just to fill in the gap. So sometimes, you see, when you read the questions, you should have an idea about the question. Secondly, you should have the answers. You can rule some of them out. All right, because CSF, you don't expect to get a contaminant in the CSF. So you rule out that one. Anaerobic, you don't have anaerobic organisms causing CSF. So you rule that one out. So the answers in between Listeria monocytogenes and then the strep group B. And then you know that strep group B is a streptococcus. And streptococcus, basically, you know that they are gram-positive cocci. So if this is gram-positive cocci, and here the question is talking about gram-positive ROS, even if you just want to play lotto, then you can play lotto and then say that, okay, the answer is likely to be Listeria monocytogenes. I hope you are following my discussion. Hello.
Yes, please.
Yeah. So some of the questions, you can just play around them and know that this one there is ruled out. This one, it cannot be possible. Then you are making sure that at least you are getting close to the possible answers. All right. As I think in our discussion, I mentioned this question, and I just want to show up. Upon review of a sputum gram stain, all right. Upon review of a positive sputum gram stain, the supervisor knows that the nuclei of all the neutrophils present in the smear are staining dark blue. The best explanation for this finding is this. What is the best explanation? All right. Then even here, I think the answer has been highlighted already. So the slide was inadequately decolorized with acetone and then alcohol. All right. The sputum smear was prepared too thin. That is not the answer. The cellular components have stained as expected. That's also not the answer. The iodine was omitted from the staining procedure. That's also not the answer. I hope that I tried to explain this thing during the gram staining reaction, that you are dealing with neutrophils. Neutrophils don't have what do you call it? Cell walls, and therefore you expect them to stain gram negative. And gram negative staining means that they have to stain red. So instead of staining red, now they are staining dark blue. So it means that there was under decolorization. There was inadequate decolorization. And this question shouldn't worry anybody if in case you come across it. Is that all right? All right. Okay. Right. Tubercle bacilli are specifically stained by, yes, you can help us with the answer. The tubercle bacilli are specifically stained by crystal violet, 1% acid fusin, methylene blue, and carbofusin. Yes.
Carbofusin.
Carbofusin, sure. Because for it to be stained, for the tubercle bacilli, it has to be able to pick up the primary stain, which is the carbofusin. All right. Good. Good. There's also in a suspected case of Hansen disease. Remember Hansen disease, leprosy.
Hello.
Hello. Somebody want to ask a question? Yes.
Yes, my name is God. I have a little catarrh, so maybe my, but we wanted to know why the other answers are wrong, but we have the right one to be those ones. Although we may know the answer, but we wanted to know why.
Why that's okay. All right. Okay, thank you very much. Why the other answers are wrong. So, for example, crystal violet is used in gram staining. Remember, you said that in tubercle bacilli belong to the mycobacterium group. The mycobacterium group, because of their working cell wall, they cannot even be stained properly by gram stain. Okay, so if you are dealing with tubercle bacilli, crystal violet is for gram staining. Gram staining will not be applicable for tubercle bacilli, and therefore that answer will be out. Is that all right? Good. Then you come to acid fixing. You see, in microbiology, and for that matter, bacteria, you know, bacteria is a prokaryote. All right. Bacteria are prokaryotes. I hope you are following me. Bacteria are prokaryotes. And in a prokaryotic cell, you know that prokaryotic cell, they don't have membrane-bound organelles. That's the characteristics of prokaryotic as against the eukaryotes. So prokaryotes don't have membrane-bound organelles. So for example, in the prokaryotes, even nucleus, you don't have a true nucleus because the nucleus, because they don't have membrane-bound organelles, you cannot have nuclear membrane. Okay, if you don't have a nuclear membrane, it means that you can only have the nuclear material spread within the cytoplasm. I hope you are following it, right? So you don't have, for example, in every bacteria, you don't have let's say mitochondria, because you know that technically mitochondria is a membrane-bound organelle. And they are saying that prokaryotes don't have membrane-bound organelles. Therefore, automatically, bacteria will not have mitochondria. We have the Golgi bodies. Golgi bodies is a typical membrane-bound organelle. And therefore, once we are saying a prokaryote, bacteria is a prokaryote, it will not have a Golgi body. So those are sort of dynamics. So all the things are spread within the protoplasm or the bacteria. So if the DNA is spread within the bacteria, the protoplasm, all the other proteins are all like they are all scattered within the bacteria. What do you think will be the nature of the protoplasm of a bacteria? Will it be acidic or neutral or basic? If you consider any bacterium, the inside, will it be acidic or basic or neutral? The inside of bacteria. Yes, anybody to help us? Anybody to help us? I don't want to mention names, but anybody to help us? What do you think is the nature of the protoplasm of a typical bacteria? Anybody? Yes, Amwako. What is the status of the protoplasm of a bacterium, considering the fact that because it's a prokaryote, it doesn't have membrane-bound organelles, so all the things are scattered. The DNA is scattered, the RNAs, everything is scattered within the bacterium. So the protoplasm of bacteria, will it be acidic or alkaline or neutral? Daniel. Oh, I thought you were following me. You are following the discussion. Yes, Daniel.
Hello.
Yes,
I think neutral.
No, it will not be neutral, because remember that the DNA the nuclear material is spread within the distance, and then it is DNA, and nucleic acids. So, and then the RNAs are there. So it makes the inside of bacteria acidic. All right. So once the inside of bacteria is acidic, what type of stain will be suitable to stain a bacteria? Is it acidic stain or basic stain or neutral stain?
A basic stain.
Basic stain. So all the stains that are used in bacteriology are basic stain. So remember, we said that when we are preparing the carbofusin, we had the carbonic acid plus basic stain and not acidic. Remember, we have acid fusin and we have basic fusin. We are not going to, we can't use acid fusin because acid will not be a proper stain to stain what? Bacteria. You understand it? So sometimes you can just use certain simple basic lessons to rule out a lot of the answers. So 1% basic fusin just to confuse you. But remember, you know that acid fusin will not be used in bacteriology. Rather, it should be basic fusin. Okay. So once it's acid fusin, you rule out one. Methylene blue is a counter stain. If you do the tobacco, the answer, the preamble is tubercle bacilli. If you use the tubercle bacilli, the counter stain is methylene blue. A counter stain will not stain the organism, it will rather stain the outside. I hope you remember that. The counter stain will just stain the outside. So it will not be the stain that will be useful to stain the tubercle bacilli. All right, so we have ruled out A, B, and C. Carbofusin is the primary stain that will actually do. Remember, I've said that once the primary stain, which is the carbofusin, enters the organism, and then you have, because you apply heat, the heat will help you to enter the organism. And remember, that's why in Zetten stain, the heat is regarded as your mordant. The mordant is your supporting agent. All right, so the carbofusin is the primary stain which will enter the tubercle bacilli, and then once you have applied your water, then the cell wall will reform and retain the carbofusin inside, and then that is why it is called acid fast. Okay, I'm sure that probably those of you who joined later on did not get the initial explanations, but I'm sure that by this explanation, whoever asked the question will now appreciate why the other questions are wrong. So why the other answers are wrong. Have I answered your question, please? Hello. I think somebody asked why the other answers are wrong. I think you have been able to explain them. Is that all right?
Yes, sir.
Okay. All right. Right. So in a suspected case of Hansen's disease, a presumptive diagnosis, and remember Hansen's disease is leprosy, and leprosy is caused by what? Mycobacterium leprae. Okay, right. A presumptive diagnosis is established by isolation of organisms on Lewis-Jensen medium. Right. Is this true or false? Hello. You see, the first answer is wrong, and like the gentleman wanted, you should know why it's wrong. In the first place, Mycobacterium leprae is not culturable. When I say it's not culturable, it means that so far it cannot be grown in the lab. Remember, you can grow Mycobacterium tuberculosis, you can grow Mycobacterium osmans. Up to date, Mycobacterium leprae cannot be cultured. You can't grow it. But even if it can be grown, look at the question very well. Say a presumptive diagnosis. A presumptive diagnosis, once you culture, it is not presumptive. A culture is the actual the real diagnosis. Presumptive is like some kind of first-hand information that we want. So it means that even if it were an organism that can be cultured, if you look at the question, we are talking about presumptive. If you do gram stain and then you do a culture, you see that gram stain, if you do, let's say, uterus smear gram stain and you are getting gram negative intracellular diprococci, it is presumptive diagnosis of Neisseria. Is that right? But if you culture and you isolate the Neisseria, it's no longer presumptive. I hope that you are getting me. So in that case, the presumptive is something that you are standing on to presume that this is likely to be the infection. So even if the Mycobacterium lepra could be cultured, even if it could be cultured, the question itself is telling you that what is the quick way of saying that we are dealing with this one, and the quick way cannot be a culture. Okay, so to isolation of the organism means you are culturing it, and from the question itself, that's not what they want. So question 1 will be what? Sorry, answer 1 will be, is it true or false?
It should be false.
False. You can't take that one. Then the question, the detection of weakly acid-fast bacilli in infected tissue. Detection of weakly acid-fast bacilli in infected tissue. Will you take this one or not?
It's a true statement.
Come again. The B
It's
will
a true
say,
statement.
yes.
Yeah.
So
I will take the B.
You take the B. Isolation of organism in a cell culture. Remember, I've told you that the Mycobacterium lepra cannot be cultured. So, and even if it can be cultured, you want a presumptive diagnosis. So isolation is actually also out. Detection of niacin production by the isolation. So all these ones that involve isolation, take them out, because that is not, you see, the question itself is giving you a clue. Okay, the question is giving you a clue. And so you should not even struggle at all to get the correct answer. Is that all right? Good. Right. So our last question is, when staining acid-fast bacilli with oramine rhodamine stain, potassium permanganate is used as what? This one there is bonus. Yes.
Quenching agent.
It's a quenching agent. Even intentionally they didn't bring for this question, they didn't bring what do you call it? A counter stain. The true use of potassium permanganate is a counter stain. But if they didn't want, you see, they didn't bring that, they didn't bring it as part of the answer. Okay. So you'll be confused. So which one do I take? Even though potassium permanganate is a counter stain. But they just want to know whether you know that it is a quenching agent. And that is that. All right. Let's take this last slide for our answers and then for our questions. Which of the following organisms pick up the primary stain in the Keon staining technique? Yes. Which of the following organisms pick up the primary stain in the Keon staining technique? Yes. This one there, you should take this one there, this one there. No, don't let me mention it. Somebody should just come. Timothy. Is Timothy with us? Is Timothy with us?
So
Yes, sir. So, Portia, you have answered a lot of questions, so let Timothy answer this one. Timothy. Timothy. Okay, who can help? Hello?
Sir, let's try.
Yes, try.
Can I give it a try?
Hello?
Hello.
I can't hear you properly.
Yeah, hello, sir.
Yes, sir, yeah. C.
Hello?
Yes, sir.
But sir, the question the question is not projected, though, so I'm not seeing anything. I don't know if it's my screen.
Hello, can you see my screen? Everybody?
No, I can't see anything. So my
Yes,
screen
please.
is-
Yes,
I can see. I can see the screen.
Okay. Then probably it's from your end, please.
Wow.
I'm sure it's from your end, yes. So the question is, which of the following organisms pick up the primary stain in the Cleon staining technique? Those of you who can see the screen, which of the answers do you take? Mycobacterium, Nocardia, Actinomyces, all of the above.
I said C.
B.
C for cat.
C for cat, Actinomyces. Okay, okay. So who else has a different answer? Who else has a different answer, please? Yes. Okay. Remember, we said that kiosk, hello. Somebody's coming. Somebody's speaking. Shamati. Shamati, you wanted to, yes,
So, yes, so from this question, I think I'll go in for all of the above, but
yes.
I wanted to go in for Mycobacterium. But since these two is what I know best, and then for the actinomyces, that one I don't really know about it, but I'll just go in for it.
Okay, all right. So, but I don't know whether you were part of the discussion from the start. We said that the ZN stain.
No.
All right, the ZN stain is the same thing as the Cleon stain. The only difference is that the Cleon stain is not applying heat as you have with the ZN. So sometimes the question is just wanting to find out whether you know about Cleon stain as the same thing as what do you call it, as ZN stain. If you know this, then you know that, oh, after all, this is the same, it's talking about the same thing as ZN. So in ZN stain, your primary stain is your carbofixin, okay? The organism which will pick up the primary stain will stain as what? AFB positive or AFB, is that right? The organism which will pick up the primary stain will end up to become what? Will become AFB positive. Is that right?
Yes, sir.
And we said that mycobacterium, of course, one, but there are other organisms or other bacteria which are not mycobacterium, they are also acid fast. Okay, except that in working on those ones, you have to modify your acid because they are weak. Okay, but whether they are weak or strong, they are all acid fast. So they will pick up the primary stain. And examples that we gave were Nocardia and Actinomyces. And then we also included Azospores and then Cryptosporidium. They are all acid fast positive. And so look, if the question comes using Cleon or even the Oramine stain, Oramine, even though Oramine is not ZN, but if you do the Oramine stain, it is also reported as AFB. If you do the Oramine stain, you don't report as Oramine positive or Oramine negative. No, we report as AFB. So any question about Cleon, AFB, ZN, the organisms which are AFB positive, they are still positive in the Oramine state. or in the Oramis staining, they are also still positive in the pion staining. So please don't confuse. Those that are AFB by Zetten, they will also be AFB by pion. They will also be AFB by Oramin. Is that all right? Is that all right?
Yes, please.
Okay. Thank you very much. Thank you very much. So let's take the last question. This one too, I think in the discussion, I try to make mention. All of the following are common methods used in a direct microscopic examination of fungal infections, except so India ink. Yes, we are going one by one.
It's true. Indian is true for fungi.
Okay, very good. Potassium hydroxide. Potassium hydroxide. Potassium hydroxide.
It's true.
It's true. Lactophenolcotin, let's say, lactophenolcotin blue.
It's also true.
Okay, Leishman.
It's false.
Yeah, so you get it. So here, your answer will be the D, false. All right. Okay. Thank you. I think we are getting to almost 7:30. You close now, and God willing, we will continue tomorrow. Please, let me just make this appeal. When we started, we only 7 people, and that's so bad. And even as of now, we are 14. This 14 include myself and then the organizer, the boss. So it means that the number is still not too encouraging. So please, we will try to do our best, but the rest should come from you. If you also don't put in your best, if you don't attend, and then you want somebody to just give you the lectures or the lecture note. The lecture note is very scanty, virtually nothing to write home about. So it is once you listen to the lectures that will actually help you to grab something. All right, and we will do our best. So you don't want a situation where you say, oh, even this program you attend and still you excuse me, you fail. Nobody would, I mean, that is not our wish. But if you also just look on to the program and you don't listen, you expect that somebody will give you the recordings or something, you still will miss a lot of things. So please, let us all be serious about it. We do our best. We don't want anybody to go in for a second time and fail. Please, God forbid. God forbid. All right. Thank you so much. So tomorrow, God willing, same time.
Thank you to Grandpa.
Thank you, sir.
Thank you, sir.
Okay. Thank you too. All right. See you tomorrow. Bye-bye.
Bye.